So I would like to introduce the 2018-2019 SCOPE projects, and the first team presenting is the Aerodyne Research Air Inc. SCOPE team.
Hello, I'm Katya. This is Jared, Sam, Taylor, and Lauren, and we are the Aerodyne Air Inc. SCOPE team. This year, we were extremely fortunate to work with two incredible sponsors. Aerodyne Research, a prominent research and development firm specializing in advanced sensors and instrumentation for applications in many fields, including environmental monitoring, and the Airport Impact Relief, Air Inc., a long-standing environmental group in East Boston focused on mitigating the impacts of Boston Logan's Airport on surrounding communities. We'd like to give special thanks to Eben and David, our liaison and subject matter experts, the whole Air Inc. crew, including Chris and Gail, and especially our amazing SCOPE advisor, Scott, for making this project become a reality. You may not realize, we certainly didn't, but air pollution is the single greatest environmental health threat in the world. It results in 4.2 million deaths per year, not to mention the other numerous negative health effects it causes. We don't typically notice this around here because there's no visibly dense smog. We don't usually wear masks outside, but that is not the case everywhere. And dangerous levels of air pollution can be invisible. 1 out of 11 Massachusetts residents has asthma, and this rate is 3 to 4 times higher in high-risk communities, such as East Boston and Winthrop, which are right next to Logan Airport and a series of large roadways, all sources of air pollution. Airplanes take off and land with a very high frequency, around 20 seconds, every 20 seconds on a busy day, and once every few minutes on a calm one. We were able to experience this firsthand working in a community partner's home, right across from the airport, underneath flight path for runway 27. Not only is the neighborhood and the house subjected to the constant smell of jet fuel and noise pollution, but airplanes flying low above will emit plumes of highly concentrated ultrafine particles and other gaseous emissions, which are invisible to the eye. Boston has 4 reference air quality monitoring stations which provide very accurate data. However, this data does not tell the whole story, not even close. The public can most easily interact with this data through a metric called the Air Quality Index, the AQI. Unfortunately, the AQI is not designed to capture the high-frequency events, such as the plumes from the airplanes, and obscures a lot of the exposure-relevant air quality data. There's a reason that there are only 4 such stations in Boston. They're large and expensive, costing around $500,000 to install and even more to maintain. They also require a full-time staff to run. As a result, the closest station to East Boston is all the way in Roxbury, 5 miles away, too far to measure East Boston's local air quality conditions. The current air quality monitoring system does not allow communities to measure their local air quality, and we need data with more temporal and spatial resolution, as well as real-time availability to empower citizens to make informed, health-conscious decisions about the air that they breathe.
To combat the high cost of air quality monitors, Aerodyne Research, one of our sponsors, designed a small, low-cost, internet-connected air quality sensor, AeroDyne. These sensors record live data on the order of seconds, not minutes or hours, designed to capture the hyperlocal changes in pollutant concentrations. The low cost and small size of these sensors enable us to create dense networks to gather a more complete picture of local air quality. To pilot this system, we built a network of 8 sensors installed around the Logan Airport area. While Aerodyne Research provided the sensors, the hardware part of the system, we focused on the software. It handles first collecting all that data from the sensors, calibrating it, storing it in a database, and actually presenting it, all in a matter of seconds from collection. And this is important because the goal of our project isn't just to build this network of sensors, but actually to ensure that the data it produces is available in an accurate, accessible, and actionable manner. To that end, the platform that we built has public-facing web application that allows citizens to view this air quality in real time without an AQI obscuring it. Citizens will be able to gain an intuition for what's good air quality, what's bad, and feel empowered to make decisions about their own health, as well as advocate for policy change. On the other side of this system, we created an interface for scientists to deploy and manage networks of their own instruments. This is a force multiplier for air quality researchers, allowing them to go from working with one instrument full-time to managing hundreds, even thousands of deployed sensors in the field. They have the ability to download this data, analyze it, and generate sound, actionable scientific reports for driving policy change. One of the trade-offs in making these low-cost monitors is the loss of precision and increased sensitivity of these sensor readings to some environmental factors like humidity and temperature. We built state-of-the-art machine learning models that calibrate the sensor data in real time, isolating as accurate as possible pollutant concentrations from the messy sensor readings. Additionally, we built a mobile reference van filled with analytic-grade instruments. It can be driven to any location and provide actual ground truth reference for the data that can be used to spot calibrate these smaller sensors in the field. The impact of air quality on people's health is really hard to overstate. But with the current air quality monitoring systems, we lack the ability to gain insight into the real-time concentrations and effects of pollutants on a truly local level. Our work this year has laid the foundation for the platform that will enable us to collect and democratize this data. But the project doesn't end there.
Moving forward, all of our work is going to be supported by a startup spinning out of Aerodyne research by our liaisons, QuantAQ. They will be continuing the technical development of the platform, enabling teams of scientists to add their own instruments and set up their own networks all around the world. Our second sponsor, Air Inc., has a history of success in this area. They piloted a noise pollution monitoring and impact relief program, which is now adopted across the nation by the federal government. Using our platform and their deep engagement with the Boston community, they're going to build citizen awareness and advocacy for positive change around air quality. Our pilot network will be fully operational in June, with sensors placed underneath flight paths or near busy roadways, locations not currently monitored for air quality. Very soon, the residents of these neighborhoods will be able to see real-time data from these locations and decide, should they go running in the morning or wait until evening when perhaps the air quality is better? Or which park should they take their kid to mitigate their exposure? Additionally, a network of our sensors and platform are undergoing trials with the EPA, and another shipment of sensors will soon enter national trials in South Africa. Our ultimate goal is to democratize air quality data in every city around the world, and we're going to get here, starting with Boston, one sensor network at a time. Thank you.